Welcome to another episode of Spooky Software. Today, I have a very, very special guest, my close friend, my colleague, the one and only, the great John Wedeman. He's a hero of all time. He's a DevOps and sysadmin by profession. He's been doing this for a long time. Definitely in my life, the person who knows the most about this kind of stuff. And today we're going to be talking about something you might be interested in if you're a DevOps, a SecOps, a DevSecOps, whatever you want. If you're in operations, man, we're going to be talking about something that you might be interested in. And even if you're not in operations, my hope is today that, we will discuss something that could even interest you as someone who's not in the operations team. John, welcome. Do you want to say hello? I don't know.
Hello, it's me. You can tell I'm in DevOps for a long time because I look tired, very tired.
Yeah. That's
how you know.
Yeah.
It used to be the case that with old system admins, you could tell how wizened they were by how long and gray their beards were. I'm working on it, but we're not there yet. Someday.
Oh, we love it. Perpetuating the stereotype. Let's keep going.
Gotta be full Ratman, full Richard Stallman. That's the goal.
That's right. So anyway, today we're going to be talking about, I know this is a subject that you find very near and dear, John, which is SaltStack, or maybe just Salt if you're, the aficionado, you just want to be a little bit shorter with your naming. But so I mean, you've been using SaltStack professionally for how many years now?
Long time. 2015 is when we picked it up.
Okay, so for a while now.
Yeah, we'll leave the math to the viewers at home.
Yeah. And so I know that you have some slides, so perhaps you want to put that up on the screen so I can see, for all to see.
It's true. Yeah. I put together some quick slides about SaltStack, the automation framework from 2011.
Which, by configuration management standards, actually really isn't that old,
Yeah, I think the first iteration of these tools was 2003, maybe?
Yeah.
So it hasn't been around that long. Let's see here real quick. Great, cool. So what's Salt? Salt's a configuration manager. We talked a little bit about what that is. Configuration manager is used to be the case that when it came to configuring your servers or your computers, all that stuff was either done completely manually, there would be, I think for most admins, there was a Confluence doc that they would use.
Right.
Or if you're lucky, one of your sysadmins would be smart and would write a Perl script that worked half the time for configuring these servers.
Bash. Everybody loves Bash.
Bash, really into Bash. If you're a real graybeard, though, Perl's where it's at.
Yeah.
If you're in the 90s, that's what it's all about. But now that we live in the future, people have automation frameworks like this, and they call them configuration managers. Salt's one of them. It does a bunch of other stuff, which is really helps sell those enterprise contracts. But the main one, the thing that we focus on, is config management, because that's where this all started.
Right.
So what is config management? I think we touched on it a little bit. It's a general term for when we are setting up computers a certain way. I think most people would say servers, but you could do this with any computer. I know a lot of people who use Salt or Ansible or similar tools to configure their own laptops. And the form that takes, the vast majority of the time, there's a bunch of stuff that you can do. But the three things people focus on is installing a package, configuring, either with a text file or in a database. I know in Windows, it's everything is about regedit with a registry. Or the final one is making sure that a process, or sometimes called a service, is running or absent or in a certain state. In Saltland, this is all handled through these SLS files. SLS files are just plain YAML, but they have a templating framework on top of them, which makes them a lot more flexible. And that templating framework is called Jinja. It looks a lot like Django templates. Really easy to learn about and find out more.
Yeah.
So let's take a look.
I just want to ask you, John. So you had mentioned that people use Salt to sort of maybe configure their own laptop. So I mean, this is an interesting idea that I think would be valuable to viewers who are watching this video. Is that it's maybe if you have local development servers, right? If you have a team of 25 engineers and they all have to install the Ruby server locally or whatever they're doing, right? You can use a configuration management tool like Salt to actually do that provisioning, right?
Yeah, and you'll see a lot of that happen with when people are using tools like Vagrant for virtual environments, or
Right.
if you're doing your own setup through EC2, Amazon, Google, any number of things where you're configuring the server directly.
Right.
You'll see these config management tools are everywhere.
I mean,
Go for it.
I was going to say, I think that this is a really, really good point that, like, thinking of, even things like developer machines as part of the infrastructure that runs a company, right? And you wanted to do all of these things that we want to do on servers, have them be reproducible, have them work smoothly, maybe be cross-platform, all of these things, right, are still problems on local machines as well, right?
Oh yeah, this stuff comes up all the time. It's nice to think that everything can fit in a Docker container, and most of the time, yeah, that's true. But there's tons of exceptions even now where you still need to do raw server configure management.
True.
Like I think even now it's still not recommended to put a production database in Kubernetes or Docker, just due to the driver issues, right?
Something like this, yeah. I personally have never put a database in a container unless it was like, a test server or something, right?
Yeah, and there's good reasons for that because there's a lot of fun exceptions that can happen that can corrupt your data. So anyhow, let's take a look at what one of these SLS files look like. Pretty simple. This is an example of configuring Nginx. So this follows a really simple YAML format. You can see that it's a dictionary that has a couple keys inside of it, and then we pass args to these. If we want to think about these as the IDs of the particular state that we're setting, and then these are functions. In Salt, they're called state modules. These assert that the Nginx package is installed. These are arguments that go into those. And then, so that's our package. If we want to do configuration, really simple thing here where we say we want a file. It comes from somewhere else in our Salt config. We template it, and this file requires that the Nginx package is installed. Finally, the common thing to do is to make sure that service is running. And this is just a simple way to look at that, where you put a similar requirement that the configuration has to be there and passed before we try running. So this simplifies a lot of like manual code that you would have to write for a repetitive task, where we're saying just these simple things: install these packages, set this configuration, make sure the service starts up and is running.
Yeah. So one thing I'm noticing right away, and this is one of the things that attracted me to Salt to begin with, is that this is a very declarative way to describe configuration, right? So we're not saying things like, for instance, this middle state here, this one where we're putting a file onto a server, right? And that file is like has some kind of like templating, right? And maybe has like it's using variables in there, right? There's no description of like the step to like copy that file to the server, or there's no like if statement here to say like, oh, if it exists, then don't do anything or whatever. That's kind of all inside of this file.managed function, right? And this is just a declarative description of what you want.
Yeah, the term that gets tossed around a lot when we're talking about Salt state modules is idempotency, which you might recognize from HTTP verbs like put or post. Post is considered idempotent where put is not. Or is it the other way around? I forget.
Doesn't matter.
The important thing is idempotency is the thing that's stressed with Salt. Really simply put, idempotency means that it's a thing, an action that I can perform multiple times without causing that action to happen again. So just about every Salt state module does a check to see if we've already done the thing. So for instance, if I'm installing the Nginx package, inside of that Salt state module is a check to see, oh, do we already have the Nginx package installed? If so, we can skip this step. And you'll see the same thing throughout the rest of these. With the file, it's check if the file's there, does it match what we want? We don't have to copy it again. Or the service, if it's already running, if it's already enabled, we don't have to do anything.
Right.
And that's what they're referring to.
Is that, why are we so excited about idempotency when it comes to these configuration management tools? Is it for speed, or is it for safety, or maybe some combination? Or is there something else maybe?
It's one part speed, definitely. The other part, because it's definitely faster not to do something.
Of course, yes. It's always faster
Right?
not to do than it is to do, right?
Other part is that if you're asserting a state, sometimes changing that state can involve taking things down or taking them offline. For instance, right here in this Nginx state, you can see at the bottom I have a watch statement.
Mm-hmm.
That watch statement means only restart Nginx if this file has changed. So if part of that change detection, I can set up kind of a quick deploy system. I can put in different checks or different safeties on when I want to update, when I want to deploy, because I don't want to take down Nginx all the time, right?
Yeah,
I
of
only
course.
want to update it if I have to.
Makes sense.
So that's one of the things that's baked into Salt's design is considerations for things like when do I want to restart? When do I want to take things down for a moment?
Of course, of course.
So we can move on from that to some of these other terms that come up. I just put in here things that were confusing back in 2014 or 15 when I was first reading the docs. They don't define things super well, but if you know these four things, you've got pretty much all you need to know about Salt. I think we've already talked about states. Those are the things that are in the SLS files. Salt calls a lot of things states. For instance, if we're talking about state modules like package installed or file managed, we could also be talking about state declarations, which this entire file represents a state because we're talking about Nginx. So you'll see that a lot. Usually when you're looking through the reference docs, you're going to want to find the state modules to build out your state that you want to make. For instance, package installed, service running, things like that. A little more confusingly, Salt has something called execution modules. These are the functions that Salt is calling underneath the hood. And if you happen to be in the command line with Salt and you just want to check something real quick, like let's say, is my user in this group? You wouldn't use a state for that, although you could. It would be easiest to do an ad hoc command, and that's what these execution modules can do. You usually don't need to know about them unless you're interested in some of the underlying stuff, or if you want to do a quick check of some kind. So that's that. They're the functions under the hood that are not item necessarily. They just do a thing. Next up are grains. You might be familiar with these if you've heard of other configuration management tools. A lot of them call them facts. They're just properties of the system that we're on. And Salt figures this out locally from the agent that's running on the computer in question. So there's some examples later on of what this looks like. So I'll just skip over that real quick. Pillars are configuration that's set by the admin or the user. This is the configuration that we want to assert on the machine. I think some places call this just straight up config or something like that. But in Salt, everything has to be a pun. So grains and pillars are what we get. Let's take a quick look at what these grains look like.
I love puns in my software, John.
Yeah, it's questionable because some of their stuff gets complicated. I think they drop the puns later on.
Oh, of course.
So, like, do you really want to remember what's a grain versus what's a pillar? If you're new, it can be confusing.
Yeah.
But at least the puns give you a unique term that you can use to talk about this stuff. I know this comes up in mathematics a lot, where people invent just brand new words for things because it's the easiest way to refer to that without mixing it up with something else. So let's take a quick look at what an example execution module would look like. I think the example I gave was listing users. Here's what that would look like on the command line. It just straight up lists out these users. This might seem silly if you're used to using like a user ad or just checking Etsy password to see what users are on there. The key with Salt is that these modules adapt to whatever OS you're on. So if you're more of a graybeard, you might be used to changing which command you use to check which user. Salt knows that underneath the hood. And so I can just call this one command across many different types of machines and get back the result I expect. These are all the users on that machine. I don't have to remember which one's user ad versus ad user or anything like that.
And just to kind of clarify for my own learning here, John. So this user.list_users, this is a execution module. There, I guess list users is like a function in this user execution module or whatever, right?
Yep.
And this is different from a salt function or sorry, salt. I apologize. A state function or a state, because this is not necessarily idempotent. This is just a function a remote execution function you may use in a higher level state function. Is that what you're saying? But you can also, of course, use it just to grab information in this case, right?
Oh, yeah. Yeah, that's absolutely right. So an execution module, if you're in context like an SLS file, you wouldn't call it directly. You would only call state functions there.
Right.
But we know that underneath the hood of every state function, Salt is using these execution functions to figure things out. So you can call one directly if you feel the need.
Right. And so in this case, we can imagine that maybe there's a state function which is like user.created or something, or user.exists, right? And this is the function that ensures a user of some name is on the system. And under the sheets, it may do its check with like user.listUsers, for instance.
Exactly. Yeah. If you want to do ad hoc actions, that's what the execution modules are for.
Makes sense.
In a way that is more cross-platform. One of the things that, like, anyone familiar with configuration management will know things like Puppet or Chef or a lot of these other configuration manager tools. The reason why Salt entered that market and was pretty successful is because, unlike Chef or Puppet, this one is based on Python. I think the others are based on Ruby. And the big difference is not necessarily that it's such a great language. It's that Python, for one reason or another, just has better Windows support than Ruby does. So Salt actually supports managing Windows servers right alongside your Linux servers. And for a lot of enterprises, that has been a huge selling point. So we can move on to talking about the grains, the other term that we dropped. Like I said, grains are properties of the system that Salt gathers when it's on there. So for instance, here's a listing of grains. I'm using the grains execution module to see them. And you can see it tells me things like information about the disks or this particular CPU, or if I have something special about the SSDs on this machine. And I can call later, I think my next example is getting one. Yeah. So here we are taking a look at one of the grains. For instance, I can see all the IP, 4 interfaces are on there. And there's this mini query language where I can traverse the tree and get straight to Docker's IP. So these are just quick examples of how you can use the grains module.
I think I also, I apologize. I didn't mean to cut you off there. I think I also saw people using some kind of maybe like plugin or something with Salt where they were able to add grains to like an EC2 instance with like AWS information, right? It might be like an EC2 like machine type, right? The VM type, or maybe the size of the VM, or maybe what like security groups it's in, or something like this. Information from the cloud it exists in, right?
Yeah. Anything that's local to the machine, that's considered to be a grain. And those are utterly pluggable. You can write a plugin, or there's probably already one that exists that will gather that information for you,
right,
and make it available. Do I have another example? The next up, we're going to talk about pillars, which are different than grains. These are properties that we're imposing on this system from configuration. An admin or a user might set this. In this example, we're setting the server name for the Nginx config that we set earlier. And here we're looking at a preview of what that Nginx template might look like. You can see we're using Jinja to grab the Salt pillar that we set above. In this template, you can see it does a mini query lang to traverse the tree from Nginx to server name to get cool.example.com. That gets set as a Jinja variable, and then interpolate it inside of this configuration. So that's just a really quick example of using these pillars to assert some config on this machine. There's nothing about the machine itself that says that this is cool.example.com. So the pillar asserts that that information is going to happen for this box. Next up, let's try putting some of these concepts together. Here's a rough outline of what that directory structure would look like. We've got our pillar. We have a top file. In pillars and in Salt modules, these top files specify which box ID goes with what module. So you can kind of see what's going on down here when we've got the Nginx config that we had shown in the earlier example. We have the Nginx config template in a file structure. And so this top that looks like this references this Nginx file, which calls on this one to figure out what configuration to give Nginx. And like we saw before, the pillar that we set applies down here. So you can see that there's this division between configuration that we want to impose versus how we're setting up our state. And these things are separated on purpose so that we can start categorizing our servers. For instance, this one's a web server because it has an Nginx server on it. We might have one that's a database, and we can manage that through the names that we give these nodes. And that's why they have this glob-like syntax. I didn't include an example here, but that's typically what you would do. So continuing to put it together, yeah. Once you have these files set up and you've got a config and it looks good, the command that you're going to run a lot if you use Salt is the state apply. State apply is an execution module that applies the state that you've set up in these directories. I think it used to be called high state. So a lot of people will say, I'm applying high state to this machine to assert all of these things that we set up in our configuration. And the idea with high state is that it itself will be idempotent. So you should be able to run this twice, and on the second time, it'll say no changes because everything has already been applied, right? So that's just a super quick overview of that stuff. The rest you can figure out from the documentation. But I feel like once you've got a really high level overview, the docs can carry you the rest of the way.
Fantastic.
That makes sense, sir?
I mean, it makes sense to me, you know.
True.
And so I think we had spoken a little bit about this. I think there's maybe one more slide. I'm not sure, but I was going to wait till the end. I think we spoke a little bit about this before we actually got on the call, but you know, and I think you even mentioned like a specific example of where Docker containers might be problematic. But, you know, I think a lot of people these days, like the sentiment I get is people really like to sort of build like some kind of roughly immutable artifact, right? So maybe they build a virtual machine and they kind of stuff it with all the things that it needs and then they go have it run, or maybe they're building Docker images, right? And then they will, you know, light these up and, you know, have these managed by some kind of orchestration, like you mentioned Kubernetes, for instance, right? But the general idea, right, is that you have this kind of artifact that you build and then put it somewhere, right? Whereas this is a little bit different, where you sort of have these like machines that are like Play-Doh and they're ready to be configured, right? And we might change them on the fly while they're running, for instance, right? So maybe you could talk a little bit about how Salt still has a place in today's world, despite everybody being interested in these kind of immutable artifacts, and where you might want to still continue to use something like Salt.
Oh, yeah. Well, I'll go ahead and put up the last slide.
This is a good backdrop. This is an excellent backdrop, John.
It's the perfect backdrop. And we can explain the picture later. But yeah, so I think even back in 2011 when Salt came out, it was really common for people to make AMIs, right? Or a machine image or a virtual machine image, something like that. And they would configure it not manually, but script. And often if you were applying the same configuration to lots of different machine images, it was easier to use one of these configuration managers to do it. So you'd combine it with something like a machine imaging or something like Packer you might be familiar with.
I have used Packer in my day, yes.
Yeah, right. So you can generate a lot of machine images that way. They can have a lot of variance between them, and you can manage that with a configuration manager. But immutable infrastructure only goes so far. There are certain things that like you don't want to handle in an immutable infrastructure kind of way. I think the most common example is people talk about databases, right? Or you might talk about a server where mutability is just necessary. I think that happens a lot of times with VPNs or similar networking appliances. You can't just rip them out and replace them. They have to be managed in a semi-mutable way. So Salt still has a lot of places there. where you want to adapt these unique infrastructures, or you need a custom management solution that is not a case that's covered yet by Nomad or Kubernetes. In fact, you could build your own Kubernetes with Salt. I've seen it done, but it really is better to stick with something like Kubernetes or Salt or Nomad in that case.
Yeah, yeah, and also, one thing I wanted to add is I definitely know that there are people who are using both state and execution functions, execution modules in Salt that, like, for instance, manage Kubernetes, or I'm sorry, I apologize, Docker images, right? Docker image.installed or something, is probably a module, right, where you can ensure a server has a Docker image there, right, and it's pulled from this particular repository, or some services running, and like, you want that service to be a Docker container, right?
If you need more control than what Kubernetes or Nomad gives you around container lifecycle, configuration management tools like provide that.
Yeah,
they can give you really exacting control over what happens when I take this container offline.
Yeah,
things like that.
There's one thing I thought you were going to mention, John, which I'm surprised you didn't. Is another thing is, like, if like tomorrow, like, some security vulnerability in OpenSSL comes out, and we have to update like hundreds of servers to, like, get the latest OpenSSL, right? Or maybe TLS, right? Some kind of whatever. It's like you don't want to, like, rebuild 100 images, right? You just kind of want to push out, like, a package.installed OpenSSL version, next, right? That doesn't have this bug or whatever, right?
And if you have a Salt-based system, doing that kind of remote execution where you need to update thousands or tens of thousands of machines very quickly, and you don't have an entire container pipeline ready for that, Salt can make that happen, especially if you have physical infrastructures, when this comes up a lot, right? You can't just physically go and swap out 10,000 servers. You need to go in and update them.
Right.
So automation frameworks like Salt, or ones that track an event bus like Salt does, make this a pretty trivial task compared to completely redeploying an immutable infrastructure. I know some enterprises have the money and time for that, but for a lot of startups, having this kind of capability is crucial to staying on top of things.
Indeed. But this beautiful picture that's been on my screen for a couple minutes, what's going on here, John? What is this?
It's a good question. So Thomas Hatch, the dude pictured, is the author of Salt, and he's the reason why there's so many Salt puns. It turns out he just named it after his hometown, which is Salt Lake City in Utah. Near Salt Lake City in Utah is the Salt Flats, of course, where a lot of things are filmed. So for some reason, back in 2017, I'm not sure why, a marketing firm convinced them to go with a space theme for their conference. And so him and the CEO, you can look it up on YouTube. There's a video from Salt Conference 17 of them running around in silver jumpsuits, shooting space guns at nothing in particular. And it's probably the most fun I've had watching these adults, these very serious software developers, just being ridiculous, absolutely silly. I think here he is being shamed for having done this.
Fantastic. Do you think that photo shoot was idempotent? I don't know.
I don't know what they were thinking. It's one of the mysteries, but it worked out. Their company got acquired by VMware. I think last year, right? Or was it? No, 2019 is when that happened.
I had heard this, but I don't remember the date for sure.
Oh yeah. Well, I mean, hopefully Thomas Hatch cashed out.
He bought 1 million of these suits. He's got a whole closet full of these suits, paid for by VMware.
Because he's been working on this thing for a decade now, so he deserves it.
Okay, John. Well, I think that's pretty much we're the end of your slides. So
that's it.
Is there anything you'd like to leave the viewer with besides the stuff that you discussed?
I know we did a quick overview of this stuff. There's a lot more that you can do, and it's worth learning about some of the underlying stuff that's going on these servers. Even though it's really like Kubernetes, Nomad, they're very exciting tools, but they do obscure a lot of the underlying system architecture. It's worth getting to know this stuff because it comes in handy.
Yeah.
Especially when you're trying to diagnose issues with, say, your Kubernetes cluster.
Indeed. Someone who has spent more time than he would like to admit diagnosing like container networking. It's like I really
Yep.
wish I didn't have to. Yeah. All right, my man. Well, it's been fantastic having you. Hopefully this is not the last time, we see you on this channel. But it's been great. So I think we'll just end it there.
All right, let's leave it there.
See you, John.
See you around.
Bye.